Hey guys, today we're going to talk about solving one and two-step equations. Equations are expressions with an equal sign. As you can see here, I've got several written on the board. Let's start off by looking at some terms that we'll be coming into contact with as we start working with equations. The first term is constant, and that is a term whose value will not change. Remember that constants are things like our numbers. Like 8, like 3.5, like -4/5. A variable is a term whose value may change. Okay, we usually will use letters to represent those. And then a term which you may not be familiar with is the inverse operation. And that is the opposite operation that will undo something. So I have down on the bottom here, addition and subtraction are inverse operations. Multiplication and division are inverse operations. Squaring something and then finding the square root of that is an inverse operation. So if we are subtracting something and we want to undo that, we would add by that value. Let's look at a few examples. Here we have w plus 4 is equal to 11. Now when we're solving equations, what we really want to do is we want to get this variable here all by itself. We want to isolate that. Okay, that means to be all by itself. And in order to do that, we're going to be doing some inverse operations. But while we're doing that, we need to maintain the integrity of the equal sign. What that means is the value on the left here is equal to, or the same as, has the same weight, has the same value as what is on the right. Okay, so it's kind of like a balance. If you do something to one side, you have to do the same thing to the other to maintain that balance. So with w plus 4 is equal to 11, we want to find some number that when we add it to 4 will equal 11. If we look, we have a plus 4, and if we want to get rid of that 4 on that side, we have to, well, subtract 4. So 4 minus 4 would be 0. And then remember, we need to keep the balance on our equal sign. So whatever we do to one side, like on the left-hand side here, we have to do to the right-hand side as well. So if we subtracted 4 on the left side, we have to subtract 4 on the right side. 11 minus 4 is 7. So in this case, w, our variable, is equal to 7. Let's double check that. We can substitute 7 in for w. 7 plus 11 is equal to 11, and 11 is equivalent to 11, and that works out. In the problem on the bottom, we have c minus 5 is equal to 12. Well, again, we have a minus 5 here. And in order to get rid of that minus 5, we need to add 5 to both sides, because you want to move all of our constants over to here, to the right side. So minus 5 plus 5 equals 0. And remember, we need to keep our balance, so if we added 5 on this side, we have to add 5 on the right side as well. So 12 plus 5 is 17. In this case, c is equal to 17. Let's double check. We can substitute 17 with c, or c with 17, excuse me. So we have 17 minus 5 is equal to 12. 17 minus 5 is 12, and that is equivalent to itself, and that works out. So with our next example, we have 6m, and that is equal to 42. Now the 6 and the m are connected by multiplication. So we can't just break them apart by adding or subtracting. We have to do its inverse operation, which is dividing. So we're going to divide 6m by 6, and that is going to leave us with m by itself on the left-hand side. And remember, we need to keep our balance, so whatever we do to the left-hand side, we have to also do to the right. So we'll divide 42 by 6 and get a result of 7. So m in this case is equal to 7. Let's double check that. 6 times 7 is equal to 42. We substituted in the 7 for the m. 6 times 7 is 42, and that is equivalent to itself, and that one works out fine. Our next problem is 1/5 y is equal to 10. Now, fractions generally cause people some problems. What we're going to be doing is we're going to be, since the 1/5 and the y are connected, okay, again, we can't just subtract or add those, but a fraction, the 1/5, is division. So in order to undo division, we have to multiply. And when we're undoing our division and multiplying, we're actually going to multiply by the reciprocal of the fraction. But since when we do the reciprocal of 1/5 to be 5 over 1, we'd get a 1 in the denominator, we really don't need to write the 1, so we're not going to in this case. So we're just going to multiply 5 by 1/5, and that will equal 1, so it will leave 1y on the left-hand side. Come over to the right-hand side, we do 10 times 5 and get 50. So y in this case is equal to 50. All right, so let's go and double check our answer. So we substitute y in with 50. So 1/5 of 50 is 10, and then 1/5 of 50 is 10, and 10 is equal to itself, and that one works out fine. So those are some examples of one-step equations. Let's put two one-step equations together and see what happens. And these are our two-step equations. Now, when we start working with more complex equations, we first need to look at what's here, and then we have to understand that we need to combine like terms first. So if we look at our first example here, we have 3x plus 4 is equal to 16. We have one x term here, and it doesn't look like any others, but we do have some constants. So we have plus 4 and we have 16. So when we start doing these two-step equations, we have to think about the order of operations. Usually we would start out with grouping symbols and then go to radicals and exponents, and then go to multiplication or division, and then finally go down to addition or subtraction. Well, when we're solving equations, we have to do a reverse order of operations, so to speak. So we're going to be starting out working with our adding and subtracting first when we are solving equations. So here we have a plus 4, and we need to get rid of that. So in order to get rid of that, we're going to do its inverse operation. We're going to subtract 4. So 4 minus 4 is 0. And then remember, we have to keep the balance on our equal sign. So we've subtracted 4 here. We need to subtract 4 on the other side as well. So 16 minus 4 is 12. So I'm going to take my remaining pieces, my 3x and my 12, and rewrite my equation. So with 3x is equal to 12, again, that 3 and the x, they're connected by multiplication. I need to do the inverse of multiplication, which is dividing. So I'll divide 3x by 3. That will leave me with x by itself on this side. And then in order to keep the balance, I need to divide 12 by 3 on the right-hand side and get 4. So x in this case is equal to 4. Let's double check that. We have 3 times 4 plus 4, and that's equal to 16. So 3 times 4 is 12, plus 4 is equal to 16. 12 plus 4 is 16, and that is equal to 16. And that one checks out. And here we have negative 2x minus 6, and that is equal to 14. So again, we look at our combining our like terms. We have a negative 2x here, no other x's, but we do have two constant terms. Let's put those together. So we have a minus 6 here, a negative 6. In order to undo that 6, to fill that hole, we need to add 6 to it. So negative 6 minus 6, or negative 6 or minus 6, whichever one you prefer. If you add 6 to that, that will equal 0. Keep our balance. We added 6 on the left-hand side, have to add 6 on the right-hand side. 14 plus 6 gives me 20. Let's take my pieces and rewrite a new equation down here. So I bring down my negative 2x and my 20 and my equal sign. So I need to get that x all by itself. I need to isolate that. So I'm going to divide negative 2x by negative 2. So when I do that, x will be by itself, and then I have to keep the balance on my equal sign, divide 20 by negative 2, and get negative 10. So in this case, x is equal to negative 10. Let's double check that. Negative 2, and replace x with negative 10 minus 6 is 14. Negative 2 times negative 10, negative times a negative is a positive, leaves me with positive 20 minus 6, and that's 14. 20 minus 6 is 14, and 14 is equal to itself. So that one works out good. All right. And here we have 1/2 h plus 4 is equal to negative 21. So we look here, we have an h term and no other h's. But we do have our constants which we need to combine. We have a plus 4 here. So we're going to end up doing this inverse operation, which is subtracting 4. So 4 minus 4 is 0. And we need to keep the balance on our equal sign, so we need to subtract 4 on this side. So negative 21 minus 4 is going to be, oops, that should be a negative 25. So let's rewrite our new equation with our pieces down below here. So I have 1/2 h is equal to negative 25. So I need to get rid of this fraction. Remember, fractions are a form of division, so in order to get rid of them, I need to multiply. In this case, I'm just going to multiply by 2 over 1, or just 2, because I need to multiply by the reciprocal of the fraction. So 2 times 1/2 h is just going to leave me with h. And then to keep the balance on my equal sign, I multiply by 2 on the left-hand side, have to multiply by 2 on the right-hand side. Negative 25 times 2 is negative 50. And let's double check that. So we have negative, or excuse me, 1/2 times, and we're going to substitute in negative 50 for h, plus 4 is 21. So 1/2 of negative 50 is negative 25. Plus 4 is 21. Oops, I'm sorry, folks. That should be negative right there. And so this should be negative 21 is equal to negative 21. All right, folks. That will do it for this one. We will definitely be practicing these in class, and I will see you when the bell rings. Oos.